So welcome to my channel Electronics on Wheel and thank you for your support. So one of our subscriber has requested that Arti More that can you share how to select the fuse relay terminal wire in a with practical example. So in earlier video I have made few videos on the fuse and I have explained about the basic of the fuses, like what is the fuse, what type of fuse and how we are using those fuses, but I have not given the practical example where you take one load and you are selecting that particular fuse. So in today's video I'm going to explain that particular thing, that okay, we will take one particular load and then we are going to select that particular fuse with the practical example. Siva and Susan also ask the same thing, so I am going to address both the queries in this particular videos. So let's start with the fuse selection. So here I will not tell about the how what is the fuse and all those things, the basic things you already know, and you, if you don't know, you can see my previous videos where I have explained in detail that what is the fuse. So let's take one recap of that. So let's see that what is the fuse. A fuse is nothing but the device offering the protection against the overcurrent and the short circuit by melting down itself. So these are the fuses which we have here. These are the relay, this is the particular fuse box. So we will try to understand also that how to select the fuse box, only this type of fuse box only, how we are going to select. All these things we are going to understand in the coming videos, but first today we will try to understand what is the fuse value for the particular load. So moving to the how fuse are selected, so these are the few of the parameters I have already told you, many other parameters also, but let's recap on that. So wire rating is nothing but on which basis you are selecting, that is continuous current. So what is the continuous current is throwing that particular wire, then environmental temperature, whether you are using for 65 degree centigrade or 85 degree centigrade or 100 degree centigrade. So what is the position or location of your fuse box, so we have to see that one. Then packaging, so packaging is nothing but the same thing, whether you are using in engine compartment or the passenger compartment, that particular fuse box. Based on that we have to see the packaging, what type of fuse you are going to use, whether midi, mega, maxi or auto. So these are the type of fuses which I have already explained. Then load characteristic, then what type of load you are using, like whether it is inductive load or resistive load or the capacitive load. So these are the parameters which you have to see when you are selecting the fuse. So all these things I have already explained in the previous videos, but now today we will see the few questions which are mostly asked in the interviews, and we have the we have to deal in day to day life when you are working on the vehicles. So let's start the first, that what are the manufacturer or supplier for the fuses. Okay, so the I'm just mentioning there are few major uh, few major suppliers. One is the PEC, other one is the little fuse. So little fuse is something which is used many times. Then we have the Eton also. So these are the some of the suppliers, major supplier which we are using for the fuse. These are the manufacturer of the fuse. So now next question come, what are the standard you are using for the fuse selection. So we have one standard like JASO standard or other standards from European Union or US SAE. So SAE we have, so from the US, and DIN standard we have from the European. So all these standards are derived for the automotive fuse, right? So these are the particular name of the standard for that particular country, but after that there are numbers, some numbers. Okay, particular number is used for the Japanese, then this number is used for the uh, US or the European countries. So JASO standard for automotive fuse is the governing standard in Japan, and Japan uh, is nothing but they have the Society for Automotive Engineers, and all standards are derived from the ISO, that is International Standard Organization. So in that also ISO, we have the particular standard by which all the JASO or DIN or SAE standards are derived. So for automotive fuse, global standard for automotive fuse is ISO 8820, which is has been stabilized under the international ISO standards. So this is the ISO 8820 standard which is used for the selection of automotive fuse. I hope you are clear on this. Then in JASO, what is the derived standard? So JASO D612 is the derived standard from ISO 8820, which is used for the fuse selection. Similarly, in USA, we are using SAE J7022, if I am not wrong, for the fuse selection. So these are the standard which are derived from the ISO 8820. So I hope you are clear that what are the fuse standard we are using for the selection of the fuse. ISO 8820 as an international, and after that we have the region wise like Japanese, then DIN, and then we have the US standard. For Japanese we are using D612, and for the US we are using J7022. Then what are the importance of these international standards? So you know already that these are the standards which are made for the to simplified, or to have one common understanding for all the automotive suppliers and manufacturers. So international standard ISO part, this you already knows. Then we have the UL standard. UL standard is safety standard basically, and stabilized by Underwriter Laboratories, a US non-profit organization. Then we have ROHS. You might have seen many times this particular standard written on the many component, and ROHS is nothing but this is a EU governmental regulation prohibits from product specific substances such as lead and mercury in order to reduce the environmental burden from the disposal of electric and electronic devices. So these are the standard which you might have seen many times on many components. ELV is nothing but the ELV directive, end of life vehicle directive, is an EU set of environmental restriction and aim to reducing the environmental burden of the car when you are disposing them. So these are all the standards which we use for the particular component or particular like fuse, or we can take any components. Okay, so international standard, you might be already aware that many times we use ISO and other things. Okay, the UL, RHSO and ELV something different. ROHS also you might have seen many times on the electronic component. So we have understood the standards. Now we will move to the how to select a or how to calculate a fuse value for a load. So in previous one of my previous video, I have already explained what are the electric loads in a car, right? So in that particular load, we will select one particular load, and then we will try to calculate that for that particular load, what is the value, what is the fuse value for that particular load. So a very common question is asked many time in interviews, and you also deal when you are working on the car as a technician or as a engineer. So what is that particular, suppose your headlamp is there and your headlamp have some problem, and you want to check whether what particular fuse value should be there, and this is the one of the load, electrical load in the car. So we will take this example and we will derive the fuse value from this particular. So when you are working as an engineer, then this particular headlamp will be having the 2D drawing, and this 2D drawing will have some information like this: that power input, then what is the nominal voltage, that nominal voltage, then test voltage. These are the information based on which we will derive our current, and then we will see the fuse value. So one example I am taking of this headlamp main beam. Okay, so here I will not take from this particular value, I will take the real value. So real value is HELA 60 module low beam light. This is the value, the 12 volt 60 watt normal light. Okay, so this is the headlamp which we are using in the our car. So for this particular headlamp, we are going to derive the fuse value. I hope you understand here that what load we are taking and how we are going to calculate our fuse value. Similarly, you can calculate for many other loads as well, like side tail lamp, you can calculate number plate lamp, you can calculate radio cassette. There are different loads, but we will take one particular load and we will try to calculate this value. And what is the requirement to calculate the fuse value, we will see. So how to calculate a fuse value? So you already know that fuse allowed capacity, I have already explained in previous video, that fuse is rated 125% of normal operating current of for the engine and passenger compartment. uh, just I have written here, but you can take this particular statement as general. It is not based on the location wise. So 125% for normal operating current. However, some of the OEMs use 135, 150 also, but we will stick to 125. This is a standard which is 99% used across the OEMs. So we will see here what does it mean. Fuse is rated 125 of normal operating current. So first we have taken the headlamp as an example. For this we are going to calculate our current. So headlamp, already I have told you in previous slide, where we have seen that we will take the power of that particular headlamp. So right now I am taking this example. So you can see here the power of this particular headlamp is 60 watt. Because I want the operating current for this particular fuse value, so from this headlamp power I am going to calculate the current, normal operating current. So P is equals to V into I, as you can see here. So our P is 60 watt, which we can get from the drawing, or we can get from the that particular whatever fuse you are going to use in that particular car if you are working as a technician. So 60 V is on V is nothing but on what particular voltage system you are working. So suppose if you are working on car, we have the 12 volt battery, but if you are working on commercial vehicle, we have the 24 volt. I have shown you earlier also here that current at 14 volt and 28 volt. So suppose if you are using for this 200 watt of headlamp main beam, then 14 volt, at 14 volt it comes 15 amps, but on 28, sorry, it comes as 7. So just half of what you are getting on the 14. So I am talking right now about the car. So what we will do, 60 is equals to, you can see here, 60 is equals to 12 into I would be 60 divided by 12, then I is equals to 5 ampere. So this is the normal operating current, 5 amps, for this particular headlamp. Now I have already have this fuse allowed capacity. The fuse is rated 125% of normal operating current. So fuse value will be 125% of the normal operating current. So so if I 125 1.25 into 5, you can do like this also, 125 divided by 100 into 5. So it will come only 1.25 into 5. So this fuse value is coming 6.25. But already I have told you that this particular value 6.25, we do not have the fuse in that, like 6.25 or 8.25 or like that. So fuse rating mostly would be 1 amp or 5 amps, mostly 5 amps. We start with the 5 amps, then 7.5, then 10, 15, 20, 25, and 30. So here 6.25 is coming, then next would be our fuse rating would be 7.5 or 10 amp. Mostly we are not using 7.5 because of the availability of the fuse, but however we can use the 7.5. Mostly we go with the 10 amps of the fuse. So here we can use the, for headlamp we can use the fuse 7.5 or 10 amps also. So these two fuses we can use. So here you can see that table. Here we have explained about the fuse rating. So give me a moment. If I erase this, so this is the particular fuse you can see here, sorry, fuse table, where you can see these are the fuse rating. Here you have the cross section of that particular wire, then you have the length of the wire, that how much length, because your voltage drop will depend on the length of the wire from one end to other end, so we have to consider the length as well. So if you see the 10 amps of fuse, you can use 0.5 of uh, CSA for 17 meter, or 0.8 for 27, 1.25 for 39. So as you can see, when you are increasing the wire CSA, then your length of the wire also increasing. It means if you are using the higher cross section of the wire, then your length can you can increase your length, so that voltage drop will be lesser. So this has one calculation on voltage drop, but as of now you just understand this thing, that how we are calculating the fuse value. So till now, if I have to summarize uh, this video, because it becomes longer video, but as of now you understand how we are going to select the fuse value for that particular load. Like we have selected here for the headlamp, you can select for any other load as well, like number plate, side lamp, many other, like injector fuel or starter relay. There are many other loads as well. Okay, so now I just want to give you the glimpse of the power distribution which we have discussed in the previous video, where we have discussed about the primary fuse and the secondary fuse. So till now what we have done, we have selected this particular fuse, or I can say, before moving further to on a power distribution, let me tell you one thing here. So here we have calculated for one headlamp the fuse value is coming 6.25 amps. But as you know that in headlamp we have the low beam and high beam. Second thing, in high beam we call it main beam. In main beam, that is called high beam, we have left hand side and right hand side. So we have actually two bulbs. So for one bulb, it is headlamp, it is 6.25, but we are using for left and right hand side. So if I calculate for two headlamps the fuse value, that would be 6.25 into 2, that would be around 2.50. If 2.5 is the fuse value, then if you see here, as I told you, 10, 15, 20, this is the value. So this is the fuse value which we will take for this headlamp. So 15 amps is the value for headlamp connection. So you can see from here also. So if I take for the two headlamps, so this would be 60 into 2, it would be 120 watts. Okay, so 120 watts is equals to 120 is equals to 12 into I, and I would come around 10 amps. This is the normal operating current, and normal operating current, then if you are calculating fuse value, then 125% of this, or 1.25 into 10, so it will come 12.50. This is the fuse value which came for the headlamp entirely for left and right hand side. Then what would be the fuse rating for this 12.5? That would be the 15 amps. As you know that 12.5 amps of fuse is not available, so we have the 15 amps of fuse, so we will use the 15 amps of fuse. So I hope you are clear when you are selecting for the headlamp. So these are the things, these are the practical things which you have to consider during the fuse selection. Suppose someone is asking you that calculate the fuse value for headlamp, then you have to understand that okay, for left hand side and right hand side, both of headlamp, you have to calculate combinedly. So this is the fuse value that will come for the high beam. And similarly for low beam also, for low beam I want to tell you that low beam, that 55 watt of 55 watt of bulb we are using. uh, so in that, it will also come around 15 amps only, that fuse value. You can calculate by yourself. If you have any confusion for low beam, then you just let me know, and then I will explain again if you have any confusion in this. High beam, low beam. In high beam, left hand side and right hand side, so we will multiply the power of one bulb into 2. That is the normal procedure. So I hope you are clear that how you calculate the fuse value in practical scenario. You can calculate for horn, you can calculate for the number plates, you can calculate for the AC HVAC system, you can calculate for the other lamps as well, you can calculate for the cluster as well. So for all the loads, we will see in future that how we are going to uh, you know calculate all these value one by one. And this is the value of secondary fuse. Okay, so I have already explained you in previous video. We have the primary fuse box and secondary fuse box. In primary fuse box, we have the mega midi fuse where we have the higher values, and in secondary fuse box we have the values which are particularly defined for that particular load or component, like for low beam or high beam or headlamp. So I hope you are clear in this. Then we will see. And so this is the one example which I have given you. So now moving, this is our headlamp. So where we are using this, and this is the value which we have selected, the 15 amps, and this is the load which is going to connect from this particular fuse. So if you see here, this is the fuse which we have selected in the secondary fuse box. After that, we have other things also, like primary fuse, then alternator, splice, and battery. Alternator is nothing but the generator. So as I already told you, we have finished till here. So I have already told you this is our source. So source is nothing but these are our source, battery and the alternator or generator. After that, we were having, this is the primary fuse and this is our secondary fuse. So as of now, we have selected the fuse of secondary box. After that, we will see how this primary fuse box is distributed. As of now, I have just given 100 amps and 200 amps of value. I will explain you in detail how we are going to select these values and how we are going to give this connection from here to here in detail. But as of now, you should be able to select all the fuse value for this secondary fuse box. If still you have any confusion in this whole process, please comment in the comment box. I will try to give you an answer. So you can select all the fuse values for these loads, pre-long loads we have seen, right? Headlight main beam, headlight dip beam, dashboard, and then radio cassette. So if you see here also, so here they have given 200 of watt. So one would be for the left hand side and one for would be the right hand side. So total like 100 and 100, then they have given 200 watt, and after that they have calculated the headlamp fuse value. So I hope it is clear. I have made other slides as well where we have seen the automotive fuse. If you want to explain again these fuses slides, so you please comment on the comment box so I can go through these slides. But you can see like quick blow fuse, slow blow fuse, then MUSB. We have already discussed what are the characteristic, what are the factors which are required for the automotive fuse, like vibration, ambient temperature, precision, reliability, what is the size and weight for that particular, then how that fuses behave on the temperature rise, what is the behavior. These are the questions which are asked during the interviews and which you should be aware during the selection of the fuse as well. Then time current characteristic of the fuses, then this is the same thing, fuse and ambient temperature, what is the behavior of the fuse on the ambient temperature. Then durability of the fuse, what is the factor of I square T and how it affects. then fuse precision we have, then load current, which I have already told you. These are the factor: ambient temperature, fusing current, maximum current resistance, selection of smallest wire size. Then this is the table which we have already discussed. Then automotive fuse rating, what are the standards which we are using, which I already told you: ISO 8820, ISO, sorry, JASO D612, and SAE J 7022. And these are the fuse type, like slow blow fuse, EV fuse. You can see the EV fuse are like this, slow blow fuse are like this, then blade type of fuse, and these are the glass tube fuse. Glass tube fuse are not used nowadays. Mostly we are using the blade fuse and the slow blow fuse and EV fuse, and we are integrating even the fuses in the PCBs, which I have told you in the power distribution. These are the time characteristic and other general specification of the fuse. This is the data sheet, if data sheet of fuse. If you want to explain the data sheet of fuse, please comment in the comment box. I will come in the next video and will explain you about the data sheet of the fuses. Thank you very much. Thanks for your support. Please like, comment and subscribe.